hit it.
How many different sums of money can be formed from one $2 bill?
Let's try something.
I have two.
You guys at the back, like I feel like, don't you guys want to meet up closer? You don't care? Steven, you're like living alone. You do want to be up closer? Alright, what's the question?
How many different sums of money can be formed from one $2 bill, three $5 bills, two $10 bills?
Wait, 3 5s?
Two 10s,
Yeah, I know this very well. We discussed it yesterday, yeah?
and one 20.
3 5s, 2 10s, 1 20. Okay, so this is a tricky question.
So one of your 5s is a 10.
Thank you.
Are we recording?
Yeah.
Alright, so there's the easy way, the brute strength way, is to just start counting up all the different possible sums from $2 all the way up to $40, $57. Okay, I think you get 23. I think, but there is a faster way to do it, and it takes a few seconds. Do you guys want a couple seconds to think about it, or should I just go?
So
Who wants a couple
I have a
seconds?
question.
Yes.
So is this the one where you have to do if they take sum of 2, sum of 3, sum of 4, sum of
It's not the sum
etc.?
factorial?
What?
Like how many different sums? That means like you can take 2 bills or you can take like 5.
Well, you can do it any way you want to do it. You're talking about the way in which to find the solution, but all they're asking is, figure $2 is a sum, right? $7 is a sum. $10 is a
Is
sum.
$2 a sum because it's only one?
Yes, it's a sum.
It is.
It's the minimum sum. We'll consider. Right, because you're only taking one thing. Yes, we'll consider it a sum. If you don't want to consider it a sum, your answer will be 1 less.
Doesn't that just make it 7 factorial?
No, wouldn't that mean my answer would be?
factorial.
I thought.
Okay, you're all looking at me, so I'll show you the faster way to do it.
Did you say this? No.
Okay, here's what I would say. What's the minimum sum? Yeah, the minimum sum is $2. What is the max sum? I think 57. Double check.
Yeah.
So all they care about are the different types of sums. They don't care how many times any particular sum occurs, right? Like they're not saying, how many times can you get a sum of $15, or how many different ways can you get a sum of 20. All they want to know are the different possible sums. Agreed? So what we can do is this. We could take the 2 5s, right? For example, we could filter them down and turn them into a 10. Okay.
That's cheap.
And then we could take a couple 10s and filter them down and turn them into a 20. Now the reason why we can do that is because, for one, by doing that, we maintain a total sum of 57, right? So we maintain the total. It's still 57. And it will work as long as we haven't destroyed the possibility of any other sum along the way. But we haven't, because we maintain at least one of each of the types of bits, right? Like we maintain 2 possibility, we maintain a 5er, a 10, and we maintain a 20. Now we had 3 5ers before, which could create a 15. But we could still create a 15 with a 10 and a 15. 2 5ers is a 10, but we could create that with one of those. 1 5, we still have it, so we can create a sum of 5. 20, sorry, with 10s we had a couple of 10s, well a couple of 10s is a 20, 1 10 covers 10, right? So we haven't, by doing this little move, we've still maintained all of the possible rungs that can exist from 2 to the max. And obviously we've maintained the max because we've maintained the total sum of dollars, right? And now it becomes really easy, except for the fact that I haven't taught you this particular section. So I might as well teach it to you in the context of this question. Okay, when it comes to the $2 bill, what I want to do is I want to calculate the total number of sums that are, the total number of possibilities that are, I want to calculate the total number of possibilities in terms of including a bill or excluding a bill, which will also include the possibility of not taking any bills, but we'll subtract at the end by 1 for that case. I'll show you what I mean. We could take or not take the $2 bill, right? There's one unique item here, agreed? So we could take it or not take it. That means we have 2 options associated with taking or not taking a $2 bill, right? We could take, again, we have one item here. We could take the 10 or not take not take the 10. So it's like if you picture the tree, you start by taking, like you take the 2, or you don't take the 2. Agreed? And then off of those, we have 2 branches for 5s. We could either take or not take the 5. It's a different choice, right? Y is for 5s, X is for 2, so there's no order there. We don't care about it. Take or not take the 10. Here we have 2 objects, though. So how many options do we have? 3. We could not take any of the 20s. We could take 120, or we could take 220. So notice your choices are always one more than the number of options, right? Oh, we'll call this F. Okay.
Subtract 1.
Yeah, so if you take a look at this, we have 6 by 2 is 12, by 2 is 24. But one of the possibilities in there, there's one line on the tree which is don't take a 2, don't take a 5, don't take a 10, don't take a 20, right? Which means you get 0. Well, we're not going to count that as a sum. But if you follow the tree in your mind, or you draw it, there's only going to be one branch that has don't choose, don't choose, don't choose, don't choose. That will count as one line, one pathway. So all we have to do is take away 1 for the null possibility, or the, I don't know, null choice. So that gives us 24 minus 1, which is 23. Is that cool? Jordan, you follow?
I don't understand the null thing.
Oh, well, you could choose or not choose the 2. So let's say you didn't take a 2, and you didn't take a 5, and you didn't take a 10, and you didn't take a 20. How much money do you have? Jordan, how much money do you have if you didn't take any of the bills?
0.
Okay, but the $0, should $0 count as a sum of money in your mind?
No.
If it does, then I would leave your answer as 24. If you think $0 shouldn't count as an option, take that option away. Because if you look at the tree, it's going to be in there. Don't choose the 2, don't choose the 5, don't choose the 10, don't choose the 20, right? And you're going to have everything else going on in the tree. Now the thing is, you're only going to see the no choice branch once. Like there's only going to be one no choice branch. It's not like you have to take away 2 or 4 or 5, right? Visualize it. There's only one way you cannot choose anything.
Yeah.
Right? There's not going to be multiple ways you cannot choose anything. That's it. Cool? That you asked is a good one because it brings up a new concept that I was going to teach you, which is the idea of having multiple pools of stuff whereby everything in the pool is identical, and you want to know the maximum number of ways you can choose something, meaning that you're not limited. In previous questions that we've done, it's always been like you have to grab 10, right? But in this situation, you can take nothing, you can take 1, you can take 2 things, you can go up to the maximum number of things, right? I'll give you one more question quickly to see if you know. Well, we'll do 2 to see if you understand that, and then we'll move on. Yeah.
Wait, just as a review, what's the benefit of adding up all the sums? Like you know how you grouped up all the 10s, made it a 20, grouped all the 5s, made it a 10. What's the mathematical benefit you get from that?
The mathematical benefit was that the way the bills were set up in terms of the specificity of the bills and the denominations in relationship to each other, i.e. 2 5s is equal to a 10. You could have a scenario where you grab 2 5s and a 10 and you get a sum of 20, or you could have just grabbed, wait, were there 2 10s up there?
Yeah.
Yeah, or you could have just grabbed 2 10s. Now if you do the mathematics to allow for both of those possibilities, then you're double counting. Because in one case you're like, oh, I take 2 5s. I take 2 elements from the third in the line, as opposed to taking 1 element from the next in the line. Well, that's a $10 sum, and that's a $10 sum.
And you're allowed to do that.
But that math doesn't distinguish between the two, so you're saying, oh, my answer is whatever, but you're way over.
And you're allowed to do that as long as you maintain a certain amount of bills within each region. Like you leave up to 2 and.
Oh, you mean why?
Yeah, why you.
Did you not hear my logic?
Oh no, I heard it, but like
you didn't get it.
some of the I didn't. Like,
Well, the way I reason it is, they're not asking for the number of ways I can get a sum. All they want to know is how many different sums exist. So it doesn't matter if I could get like a 20, 3 different ways, like with 2 10s or 4 5s or 3 5s and 2 5s and a 10 or whatever. They just want to know the different possibilities. So I thought of the lowest, which was 2. Think of the highest, which is 57, right? And then I asked myself, the degradation or the what am I looking for? The incremental values I want to maintain those minimal incremental values, which to me would be equated to at least having 1, 2, 1, 5, 1, you know, as long as you have one of each of those little denominations, then you should be able to create any combination, right? But you can't just, if you have 3 5s, you can't just chop off 2 5s and say, oh, I still have a 5, I could still make a 7, because if you just chop off the 2 5s, then you'll never be able to add up to the maximum sum. So my criteria, I'll repeat it again, maybe a little bit more succinctly. My criteria would be play with the denomination so that you still have at least one of each denomination, but you still maintain the same overall sum. If that makes any sense. Does that make sense? I think that makes sense. Yeah?
Yeah.
Yeah. Yeah. Okay, so, oh yeah, so if a meal consists of at least one item to be chosen from 24, I don't know, let's say 10 cans of Coke, 5 bags of olive, and 1 apple. How many meals can you make? Okay, so who wants to give me the answer very quickly? Who wants to give me the exact same logic as before? Who would like to give me the answer very quickly? A meal has to have at least one thing in it. You build a meal from 10 identical cans of Coke, 5 identical bags of olives. Did I say 5 bags of olives?
Yeah.
And 1 apple. It was supposed to write potato chips. I would take a bag of olives over.
One cake or all
That's gross.
1 cake of can. 10 can of Coke. 10 cans of Coke. I got no sleep last night, guys. I had Mexican food nightmares last night.
Would it just be 11 times 6 times 2 minus 1?
Yeah, 11 by 6 by 2 minus 1. Is there an order here? No, because 1 is olives, 1 is Coke, 1 is apples. You add one choice, you add one choice, the no choice possibility to each one of these. Just like the other question, you take away the null set. That 66 by 2 is, what is that, 132? Is that 131?
Yeah.
Yes, move.
What?
What but? What?
Aren't they
That's, yes, they are identical. So what does 11 represent?
So why does it matter?
Why does what matter?
So are you saying it's like a wardrobe thing where you have to choose one of each?
No, it's not like the wardrobe thing, because the wardrobe thing, you had to take one of each item.
Sorry, I thought you had to take one of each of those.
You don't have to take one of each. You could take 1, you could take 2, you could take 3. You could take a maximum of 16 items. Got it?
That would be one hell of a meal.
This sounds like a meal. It sounds like college life.
We'll be in college.
10 cans of Coke.
No, this is like
5
Segum's
bags of
dinner.
olives.
Guys, I'm just trying to teach a concept. Do I have to really make it like...
Doesn't
Yeah,
jump
don't
off
you
the
remember
page
president,
for
vice president,
I'm
or
sorry, I'm not
burger?
trying to make it jump off the page.
me. Burger.
I want to make sure that you do it on the test. That's all I care about. It doesn't have to jump off the
That's the
page.
one.
I'm not Miss Shevins. You can go get stickers at Miss Shevins or Miss Kira Georgia.
Oh,
Miss
she never
Shevins
used
gives
to-
amazing stickers.
She is-
Sir, could you explain it again?
She had a
Explain it again.
It was good. That was my favorite.
What am I doing wrong? Can you what's the minimum meal size you can have?
1.
Yeah, it can be either a can of Coke or a bag of olives or an apple.
Yeah.
It's the maximum number of things you can have in a meal, all of them together, right? So, seems to me, when it comes to the cans of Coke, if X corresponds to the number of cans of Coke you can choose from 0 to 10, how many options are there with cans of Coke? Take none, take 1, like, you have the 0 case, it's like, I took none, or I took 1, or I took 2, or I took 3, or I took ... 10, or I took 11. Sorry, I took 10. And then for each of those 11 branches, right, like, you have 11 branches that go 3, 4, 5, 6, 7, 8, 9, 10, 11. This was the case where you took no Coke, 1 Coke, 2 Coke, right, 11 Coke, right? Now for the no Coke case, you're going to have 6 options for the olives. For the no-coke cakes, you could still take no olives, 1 bag of olive, 2 bag of olive, 3, 4, 5. But so they're going to be 6. So that 6-finger spread is going to exist for each of these, right? It's going to be duplicated. And then for each of those fingers, 6 fingers, you're going to have 2 fingers sticking off each of those. And only one of the pathways is going to have no Coke, no bags of olives, and what the hell is it? No apple. That's not a meal. It's not a meal. Yeah. So you got to take it away. I ate Mexican food late last night. I had a horrible night. Awful. I had to work out at 4 in the morning to get such a... What?
It was a nightmare about Mexican food?
I ate something, and then my wife was hungry, and I didn't have to. I said, I'm not making anything for dinner. And she's like, let's get food. She's like, let's get this. I'm like, no, let's get Mexican food from Milagro, which is a good Mexican place in Young and Lawrence. And we went, and it was just, I ordered too much. I got too excited, and I ate this huge amount of food. And it was too much, and she slept with the kid downstairs. I had the whole bed to myself. I was so excited I couldn't sleep. I was tossing and turning. I dreamt that my South American linear algebra teacher from first year university. He used to talk like Mr. Gallo. He had a big mustache. He didn't have a ponytail. Yeah, that I was cheating on it was all fiction, that I was cheating on a test, and that he caught me cheating on a test. And that they took me to the dean, and they said, we're going to kick you out of engineering, or you could do community hours. And I had to go to, I ended up in, it's a dream, right? So all I knew was it was summertime. I was in Queens, New York by myself, chopping cabbage in the back of a Mexican restaurant. And I had to do that for the whole summer. And then I woke up, and I'm like, I can't do this anymore. Yeah.
Just sign it or just put initial date on it. Today's date.
Today's date?
Yeah.
Okay.
Because I'm giving it the date.
Do that right now.
That's extremely vivid.
What's the date today, guys?
November 3rd.
Third or second?
3rd.
Good? Yeah. So don't eat food late at night, guys.
Is it only for Mexican food or all food?
I've
Like if you had a lot of other kind of food.
I've had food nightmares before, but not. I don't have them that often. But I was really like I was all like when I woke up, I was all dry and I had to have water. Now, I worked out. I had to work out for an hour just to feel better. All right. So what's next?
Can you give us another 2 examples? Is that?
Oh, there's another one.
That sounds like Josh.
For this stuff. Where's that? What page is that with the sums of money?
288.
Okay, let's see you guys do question the last. Do 23. The only thing I think we have left to do in this course is really Pascal's triangle. In this unit is Pascal's triangle. And you sort of already know it. And binomial expansion and all that.
Oh, that's in this unit?
It's in 4 and 5. What was this question again?
It was about fruits and paintings.
Let's hear it. I know it. But
Suppose the artist had 2 apples, 2 oranges, and 2 pears in his fridge. How many combinations?
2 pairs, 2 of each?
2 of each, yeah.
Yeah.
How many combinations does he have to choose from if he wants to paint a still life with? And then there's A, B, and C.
Go.
A is 2 pieces of fruit, B is 3 pieces, and C is 4 pieces.
B is 3. And
C is 4. But isn't this just split into cases and go with it?
yeah, so do.
So it's not to do with the other one.
It is to do with the other one.
How's it to do with the other one? Come on, this is from 12 factorial yesterday. My mind is a bit.
I think it is.
It's like it
Okay,
has
I'll
one-
do part A.
Okay.
2 pieces of fruit. It's
It doesn't have anything to do with the one we just did, does it?
I think it does.
Can I ask a question?
Yeah.
It doesn't matter if you have duplicates?
It doesn't. Does it? Well, you're asking me. Look at the question.
Okay.
Ask the question.
Ask the question. Talk to the question.
If you can't have duplicates, how could you choose 4 pieces of fruit? I hate you.
I hate you.
Okay, two different. Can you have two different? Jordan, can you choose two different looking pieces of fruit? Yeah, you're right, actually. What am I saying? It's exactly, you're right. Because in this question, they're specifying the quantities. Okay, but whatever, let's do it. Go, Jordan. How many ways can you choose a unique piece of fruit? How many different types of fruit are there?
3.
Right, and you got to, if you're going to do two different, you got to choose how many?
2.
Right. All right, and the other possibility for A is that they're both the same, right? How many of these different groups, Jordan, can provide doubles?
All
of them.
1, 2, yeah, 3.
So 3, but you're only taking one of them to give you a doubles, right? Okay, so that's...
So does order matter in this case?
No.
Ask the question.
What does the can do?
What does the question say?
It doesn't say.
It does.
It's combinations.
It's implicit.
Okay.
If you're painting an apple next to a pear and a pear next to the apple,
It is a difference.
I know.
But it doesn't say.
One's by Van Gogh,
But
the
what-
other's by Monet.
Read the question out loud. Read it.
Suppose the artist in example 1 of this section had 2 apples, 2 oranges, and 2 pears in his refrigerator. How many combinations does he have to choose from if he wants to paint still life?
How many, first of all, they tell you combinations.
Okay, thank you.
So how many combinations does he have to choose from if he wants to paint something with 2 bloody pieces of fruit or 3 or 4? It doesn't say how he's going to paint them.
Okay.
Maybe he's going to paint one on top of the other. I don't care. Right? It doesn't matter. They just want to know how many different ways can you bring into the painting, you know, a couple pieces of fruit. Okay, in terms of the elements that he uses to paint. It doesn't talk about then organizing the order. All right, so what do we have here for 3 pieces of fruit? We could go like that, like that, like that. Jordan, do we have enough elements to create 3 different singles?
Yeah.
Okay, how many do we need? How many of them do we need to choose to create 3 different elements?
Just one. Like one
What
from
the hell
each.
you
One
know?
from each.
Yeah, but so,
Oh, okay. So 3.
okay. 2 the same, 1 different. Jordan, how many of these can provide 2 the same?
3.
Yeah. How many do you need if you want 1 pair?
1.
Nice. And then we have to multiply that by that one can't be chosen again, right? Although it doesn't matter because it's gone. There are only 2 of each. Now, how many elements do you have left to choose from once you've?
1.
Yeah. And do you need it? Or sorry, no, they're not 1. There's 2. If you
Oh, yeah,
took
yeah,
2
yeah,
apples,
yeah,
there are
yeah.
2.
1.
And then you
So,
need.
yeah.
Is this an x by an x or an x by a y? Why is an x by y? What does this mean? Taking how many pieces of fruit? 2.
2.
And this means taking.
1.
Will that inject order? Yes, no, and why?
Yes.
No, it will not inject
I
order.
don't think
Because you could get double A single O as opposed to double O single A. Are those the same course? Are those the same with different order? Or are those actually different?
Different.
They're actually different. Do we want to count order in this question? No. Therefore, good. Do you understand the thinking? That's the thinking I teach you over and over again. Do you want to count order in the question? Mungo asked that question. Which is good. The answer is no. You do your math. I like to label with variables. If the variables are the same, you are injecting order. Well, in this case, then I would have had to remove it. But we agree that we're not injecting order because this represents doubles followed by a single. Right? And therefore, we're good.
Bless your soul.
Next case, triples.
can't
Jordan?
do triples.
Why can't we do triples?
Because there's only 2 of
3
these.
pairs.
Fine. Answer,
3 pairs.
1 plus,
no
this is
pairs.
3 by 2, which is 6, this is 7, right?
Hey,
Yes.
give it fruit. There's no pairs.
Are you guys, Kevin, are you following any of this?
That's funny.
You're good? You sure you can see from back there?
Yeah.
Okay.
Watch me laugh.
Whoa.
No questions so far? Okay, sir, for it?
Why is it so? I mean,
Because 3 choose 3 is 1,
You were feeding that.
and 3 choose 1, this is 3 by 2, which is 6 and 1 is 7. And then lastly, Corey, 4 pieces, we'll go all different. Can we do all different?
Nope. Nope.
Okay, let's do a pair and 2 singles.
No pairs.
Corey, what do we got here? 3, choose.
3, 2,
Oh, they're actually pairs.
No,
1.
you choose one of these options to represent a pair. Okay, and then 2, choose. You need them both. So if you choose double apple, right, then you need to grab single orange, single pear, right? This is a Y. These represent single choices, right? You could have double star, double circle. Corey, 3, choose. You need to come to extra help. Yes. You have 3 options. You need to take a pair of those options to which represents, it doesn't represent taking 2 fruits, it represents taking 2 pairs of fruit. Do I need to take any more? No, because I need 4 pieces of fruit. And if I go double A, double O, that's 4. Or if I go double O, double P. Right? So there are only 3 ways. You can go double A, double O, or double O, double P, or double A, double P.
So 2.
Next. Can you go triple, single? No.
Don't you need to, I don't. Oh yeah, never mind.
What else can I do? Is that it?
Yeah.
That's it.
That's it.
Sum equals 3 by 1 is 3 and 3 is 6?
Yep.
Okay. Make sense?
So sorry, could you, how do you
Yes.
get the sum?
If you don't follow that, I understand some of you guys get confused because you see this and you're like, that's 1 piece of fruit. But it's not. This represents the total number of pathways you can take a pear. And I noticed, I listed, somebody asked me a good question yesterday, like, how do I know when I look at your work in a question if 3 choose 1 means choosing 1 item from 3, or it means like choosing 4 of a kind from a whole bunch, from 3 options that could provide you 4 of a kind. That's why when I do my work, I always create some kind of
Visual.
template or visual so that I can refer back to, right? Because the same mathematical operation may not mean the same thing, right? 3 choose 1 can mean a whole bunch of different things. So you gotta know what the math means in reference. It's contextual. It's always contextual. So if I know that x in this case